Okay, we're going to be reviewing for our test today, simplifying radicals. Remember, no radical allowed in the denominator. So in this problem, there's a couple of ways we could do it. So most of you probably think we need to get rid of the radical in the denominator. So we're going to multiply by the square root of 6 over the square root of 6. Again, I don't like to multiply my two bigger numbers. I mean, it's not a huge number. I like to just leave it like this. On the bottom, I'm going to have 2 times really 6. The square root of 6 squared is just 6. And now, I don't have room to write under there, so I'll have to use another one. But think of 18 as being 9 times 2. Well, 6 is 2 times 3. So I can kind of put these two together also, all over 12. So I'm going to bring out the square root of 9 is 3. Square root of 6 is 2. Underneath the radical, I still have a 3. And out here I have a 12. 3 times 2 is 6. So this 6 is going to cancel with this. And your final answer is the square root of 3 over 2. Anybody see another way to start the problem? There is a lot easier way to do it if you notice this. Again, think of these two as underneath one radical, cancel, and you go right to your answer, and you wouldn't have to rationalize the denominator there. So it depends upon what you recognize. So maybe a good idea to look at the problem first and ask yourself, is there anything that can simplify? Okay, in this one, remember to rationalize the denominator. This time, it's not really rationalizing. Well, I guess it is, but we're going to have to multiply by the conjugate. So if I just multiply by the square root of 7, and when I end up distributing, I'll end up with a square root of 7 there multiplied by 2, so it wouldn't be gone. So I'm going to multiply by 2 minus the square root of 7 over 2 minus the square root of 7. And again, I like to leave it in factor form to start with, just in case I can cancel here in a minute. So 2 times 2 is 4. Square root of 7 times square root of 7 would be square root of 49, which is just 7. 4 minus 7 is negative 3, and here's where I said, like I said, that we can cancel. So this would cancel, and I'm really going to divide by negative 3 to give me a positive 1 here and give me a negative 2 here. So now when I distribute, I'm going to get negative 4 plus 2 times the square root of 7 all over 1, which we don't put then. So you need to watch your signs there on that one. On this one, if you think of them underneath one radical first, and you can either write that or just think of them, this 8 is going to cancel with this 8, just leaving me the square root of 5, and I'm going to break it down into the square root of 9, which then really, if I notice, square root of 9 is a perfect square, so just the square root of 5 over 3. If you did not notice that, you'd be multiplying by the square root of 9 and then have to do some simplifying. Okay, here we do need to simplify, so we're looking for perfect squares. So perfect square in 24 would be, break it down into 4 times 6. Perfect square in 54 would be 9 times 6. Perfect square in 96, and since we do notice that the 6 has been in common, we want to try that and see, and it is 16 times 6. So the square root of 4 is 2, I bring that out as a 2. 2 times 4 is 4 times the square root of 6. Square root of 9 is 3. 3 times 4 would make it 12 times the square root of 6. Square root of 16 is 4. 4 times 5 would be 20 times the square root of 6. Now they all do have the square root of 6 in common, so I can add them up. 4 plus 12 is 16, plus 20 would be 36 times the square root of 6 would be my answer. Again, we're going to solve this one, so we need to isolate the radical, so subtract 3 from each side, so we get the square root of y minus 1 equals y minus 3. Then I'm going to square each side, so we get y minus 1 equals, using your FOIL method, y squared, or the special products, negative 3y doubled is negative 6y plus 9. I'm going to get set equal to 0, so I get 0 equals, if I subtract y from each side, I'm going to have y squared, subtract y and subtract, or sorry, add 1. Maybe you can read that. Minusing y, I'm going to get negative 7y. Adding 1, I'm going to get plus 10. So I want to look to factor this. Doesn't fit any of the special patterns, no GCF, so I'm looking at factors of 10, so probably minus 5 and minus 2 would work. It gives you minus 5y, minus 2y. So I get from that y equals positive 5 or 2. So remember, I do need to check them. So if I put a 5 in here, 5 minus 1 is 4, square root of 4 is 2, 2 plus 3 is equal to 5. So 5 works. If I put a 2 in there, 2 minus 1 is 1, the square root of 1 is 1, plus 3 is 4, that does not equal to 2. So I throw that one out, and 5 would be my answer. And don't forget also we need to know how to use the distance formula, but I don't have an example of that for you.